When we are writing chemical equations, we have to write the equations and we have to balance the equations. So let's look at writing equations. If I made this statement, hydrogen and oxygen combine to make water, how could we write that in a chemical equation form? Hydrogen and oxygen are my reactants. And so I'm going to write those hydrogen and oxygen as reactants. Hydrogen would be H2 and oxygen would be O2. As a side note, I don't know if this has been pointed out before, and I don't remember mentioning it recently. How come it wasn't just H and O? It's hydrogen and oxygen. Well, there's actually 7 elements that are diatomic. 2 atoms of them make the element. Those 7 elements are hydrogen, nitrogen, oxygen, fluorine, chlorine, bromine, and iodine. And now if you look at how I wrote them just there, I wrote them crazy. Why? Well, hydrogen's one of them that's diatomic, and it's kind of an element. If you look at the periodic table, hydrogen is up in the upper left, kind of off by itself. Then, to come up with the other 7, go to atomic number 7, which is nitrogen, and you will see that the other 7 make a 7 on the periodic table. N, O, F, C, L, B, R, and I. Okay? And that's a great, easy way to remember the 7 diatomic elements. So if you see an equation that says chlorine reacts, you know it's Cl2. Fluorine reacts, it's F2. If an equation says sodium reacts with water, well, sodium is not on this list, so it's just going to be Na. Okay, so going back to this equation, hydrogen and oxygen combine to make water. Well, the rest of it's easy. Combine to make, we would draw this known as a yield sign to make water. And so what we have here on the left side, these are reactants, and on the right side, these are called products. And this is a very simple example where we only have 2 reactants and 1 product. In this course, you might see equations that list as many as 3 reactants with as many as 3 products. We probably won't see anything beyond that, but realize it can be any combination. It can be 2 things making 3 things, 2 making 1 here, 1 making 2, etc. Okay? This is just a really simple one. Now, after we have that written, we have to go in here and put something in these little parentheses. And in these little parentheses, we have to put the physical state for each reactant. Our choices for physical states of reactant, in one of those parentheses, we could put a G for gas. We could put an L for liquid. We could put an S for solid. And the 4th choice, which you've seen earlier, is the AQ for aqueous. Aqueous would mean it's dissolved in water. So, what's going to go here? Hydrogen is going to be a gas. We know that. We know oxygen is a gas, and since we said water, in this case it's a liquid. Okay, now I'm going to erase some of this stuff at the bottom so I have room to show you what's next. If we look at what we have, hydrogen and oxygen combine to make water, you'll see that on the left side, the reactants total, we have 2 hydrogens and 2 oxygens on the left side. On the right side, we have 2 hydrogens and 1 oxygen. We have to end up with that many atoms. So we can't start with 2 hydrogens and 2 oxygens and end up with 2 hydrogens and 1 oxygen. What we have is an unbalanced equation. To balance an equation, we use something called coefficients. And coefficients are numbers that appear in front of the components of the reaction. Now, what are we doing? We're balancing because this 2 oxygens making 1 oxygen is not balanced. That won't happen. So we have to make those numbers be the same. They don't necessarily both have to be 2. They might both end up being 4. But what are we going to do to balance the equation? Well, what I'm going to do is go to the right side of the equation, and if I change this number to 2, that's going to change everything after it, the H2O. So that's going to make me now have 2 oxygens. See, it fixes this problem we have of them being unbalanced, but it's going to change the hydrogen to 4. So in doing that, we fixed the number of oxygens, but we just threw our hydrogens out of balance. That doesn't mean it's wrong. That means we need to go balance the hydrogens. How are we going to do that? We're going to put a 2 here, and that's going to change this to 4 hydrogens, and now everything that we have listed is balanced. Let's do another simple one. What if I said nitrogen and hydrogen combine to make ammonia? What would you write? Nitrogen and hydrogen combine to make ammonia. Now, ammonia is one of those common names. Another name for ammonia, if we were following those rules, would be nitrogen trihydride. But ammonia is NH3. That's a common name, ammonia. Nitrogen is a gas at room temperature. Hydrogen's a gas at room temperature. And our ammonia is also going to be a gas at room temperature. When I look at the left side, I've got 2 nitrogens and 2 hydrogens. On the reactant side, on the product side, I have 1 nitrogen and 3 hydrogens. Obviously, they're out of balance because that's what we're working on, is balancing equations. You have to pick somewhere to start. Are you going to start with the nitrogens or start with the hydrogens? It doesn't matter. Just pick one. Let's start with the nitrogens. To balance the nitrogens, I'm going to add a coefficient of 2 in front of ammonia. When I do that, that changes my nitrogen over here to 2. It changes my hydrogens to 6. So I started with the nitrogens, and now I've balanced the nitrogens. What am I going to do to fix the hydrogens? I'll put a 3 here, and that will take care of balancing the hydrogens, and there's that balanced equation. Those are 2 very simple ones. Let's move up a little bit. Let's look at a combustion equation. You've heard of combustion, whether it's fuel combustion in your vehicle, combustion on your gas grill. Combustion is when something burns. And in a combustion reaction, typically, well, combustion needs oxygen, right? A fire won't burn without oxygen. And the reactions we're going to look at are complete combustion reactions. Combustion reactions, if they're complete, if there's enough oxygen around, combustion reactions will always generate carbon dioxide and water. And we're going to put this as water vapor because we know combustion reactions are hot reactions. But that's generally what a combustion reaction looks like, and what might change is what are you combusting? What is your fuel? Okay, but it always reacts with oxygen to make CO2 and water. And for this combustion reaction, our gas is going to be methane. We're going to combust methane gas, which is CH4. So now, what do we have? We've got carbons, hydrogens, and oxygens. Tally up. You might want to pause the video while you work this out. Add up everything on the left and right and see if you add it up right. Okay, and that's what we get when we add it up. Now, where do you want to start? I see the hydrogen as the easy place to start because right off the bat, when I'm looking at 4 and 2, I know that I can balance those because if I can just double this number, I can have those balanced. So let's do that. How are we going to double that number? We're going to put a 2 here, and that's going to give me 4 hydrogens, and that's going to change my oxygens. I have to be careful because I have oxygen and CO2 and water in this equation. So don't forget, to count them up in both places, if you were wondering where I came up with that 3. Okay? So I fixed the hydrogens, and by starting with the hydrogen, it's going to make it a lot easier to fix the oxygens, isn't it? Because maybe you were looking at 3 and 2 and thinking, how am I going to take those up to 6? But you don't have to. A 2 in front of the oxygen. We'll change that, and now you have a balanced equation for the combustion of methane. There are some great websites out there for practicing balancing equations. So you should just go to Google and type in balancing equations practice, and there's so many websites that are interactive where you can balance, and it'll show you how, and it'll give you hints. And I encourage you to do that, because this is something really important to chemistry, and you need practice makes perfect, and you need to be good at it. You don't have 10 minutes to balance an equation. You need to just get really good at it so that you can save time on your test.